This is the return air section of the air handler. Got 2 return air fans controlled by 1 VFD. This is your airflow monitoring station right here. Both inlet side of the fans. Return air section. Your return air going this way, obviously. Other than that, if we move to the next section, we can see the fan motors and just work our way down from there. On floating skids. These are your exhaust dampers, return air dampers, and right above you, when we step over there, you'll see the outside air dampers right there. So, not much to it in this compartment. Pretty basic, pretty simple. So.
Still within the mixed air compartment of this air handler, to the right we have our mixed air dampers that we have electronic actuators that modulate to control them. Up on the ceiling are the outside air dampers that provide outside air that is mixed in based on either temperature or if we have a minimum outside air flow requirement. There are flow stations on the outside air. It has a honeycomb director to make sure that the air is coming through nice and straight so we get a good outside air reading. Then what we have up here is an important component. These are the low temperature safeties so that if something happens with the mixed air dampers and they don't protect the unit or the coil from cooling or from freezing, then these will actually shut the unit down. So if you see a low temp alarm on this unit or air handler 1, you'll have to check both of these devices. They're both set for around 40 degrees so that if this compartment gets too cold, it'll trip the coil. And then we have a transducer for measuring filter differential pressure that is behind the camera up here on the wall. And that'll tell you when these filters get dirty. Johnson controls FEC. This is what's responsible for controlling the air handlers. There's a setup like this for each air handler 1, 2, 3, 4, and 5. They all have a similar configuration with one FEC, which is pretty much the brain, and then the IOMs, which are input-output expansion modules. The things that are noteworthy in here, we want to take a look at these safety relays. The first relay is for discharge air, high static. So if, say, all your VAVs were to close suddenly, if you had a fire smoke damper close, and you see on the BMS, you see a high static alarm, this indicator light will probably be out. If you walk up and any of these lights are out, they should all be illuminated first thing. If this one is out, then you'll re-hit this button right here. This is a manual reset that you'll hear it click and the light will come back on and the air handler will start up all on its own after that's been reset. You might want to stick around just to watch, make sure it doesn't trip again, because maybe if the condition that caused the air handler to shut down is still present, then it might shut down again. So just kind of hang tight until you see the air handler come up to speed. The low temp alarm is from the mixed air compartment. We talked about the 2 safeties in there that if the air temperature in the mixed air plenum gets too low, either one of those can trip. So again, you want to check both of those safety devices, make sure they're reset, and come back over here and you see if the indicator light's on, you're good to go. The unit should start back up and do its thing. We have discharge air smoke detector and fire alarm. These are actually doing the same thing. These relays are parallel at this time as far as the control. They look to the fire alarm system, and with it being an intelligent duct detector, if either the smoke detector goes on the supply or if the system sees an area detector, the matrix tells the unit to shut that contact down or open that contact, and these relays will drop out. So if you see these lights illuminated or off, then you need to look at the fire alarm panel. Once the fire alarm panel is reset, put back to normal, the unit will come back up to speed normally. This is our building static transducer. We use this just for monitoring. We're not controlling for building static. The control of the fans themselves, we are controlling duct static. The transducer for this one is down on the second floor, and the one for air handler 1 is down on the first floor. And we can show you where those are, or maybe Joe will remember where they are. The return fan tracks the supply fan. So as the duct static is rising and lowering, the supply fan will adjust to maintain duct static. The return fan then is going to look at that command that the supply fan is doing, and we apply a differential command to it and run it at, say, 10% less than supply fan. So supply fan's running 50%, return fan's running 40%. We have a global outside air temperature sensor that is responsible for the economizers, or it tells the economizers what to do. We have a single set point that's around 60 degrees. So if the outside air temperature is below 60 degrees, we're going to try to use the economizers to satisfy discharge air temperature control. The only thing that might override that is we have minimum outside air flow. We have a flow station on the outside air. It's not a separate damper. It is the it is the outside air damper, and we will increase that more than what the discharge air temperature PID wants to do, just to satisfy minimum outside air, because that's more important than the temperature that the air handler is putting out. Speaking of the economizers, there are 3 separate outputs for the economizer dampers. Now typically over in your other facilities, we have one control called either Econ-O or MAD-O, mixed air damper output, and you command that, and then the outside air dampers follow what that command is, and the return air damper is the reciprocal of that. Here, you need to be very careful because there are independent outputs. So if you want to override the economizers, make sure you're doing the damper to open before you force the one that you want to go to closed, so that we don't create a pressure problem inside the unit, starve the unit, and that could potentially cause some damage. Any questions?
So you don't have protection for that?
We do not have a safety pressure transducer inside for negative pressure. We have a high static that's in the supply compartment, so that if anything downstream, say VAVs or fire smoke dampers close, then it will shut the unit down. And of course we see this indicator off and it's reset with this device. We put that and then the date that we've set that. And this actually has a tube that goes over to the supply fan compartment, and it's measuring the pressure in the supply fan compartment. Excuse me. Let's see. We do have a backnet interface to each of the drives. So in addition to us commanding the drives on-off with a hardwire connection, a speed command with a hardwire connection, a status feedback, whether it's on or off, with a hardwire, and on these we have a fault, a VFD fault, that is a hardwired connection that reports to us. You can see all of those just looking in the FEC controller on Metasys. If you want to further investigate the drive, say if you want to see if it's in hand, then what you can do is look at the interface for that particular drive. Every drive has a backnet connection to that, so we can see what the frequency is that it's putting out actually. We can see current, temperatures, voltages, and faults. Very similar to what you've done on your other units. These are ABB VFDs, so you should be very familiar with those.